Okay, great. Hi, everyone. My name is Barathwaj Murali, and I'm a graduate student at Rice University. Today, I'll be presenting the work on using performance measures from the velocity domain for assessing endovascular surgical proficiency. Surgeons are increasingly using an endovascular approach for a variety of diagnostic and therapeutic cardiovascular procedures. So you can see a few examples here for angioplasties and valve replacements and that sort of thing. These are catheter-based, minimally invasive approaches that require surgeons to navigate flexible guide wires, catheters, and sheaths to access target structures within the vascular system and perform these interventions. Acquiring proficiency in navigating these flexible tools is challenging, and traditional methods of assessing performance using structured rating scales are subjective and qualitative in nature. In this work, we are interested in a set of objective and quantitative metrics that can be used for automating surgical performance assessment. We collected kinematic data streamed by an Angiomentor surgical simulator while 75 participants of varying experience level performed a set of endovascular navigation tasks. From the motion data collected during each navigation task, we calculated a set of metrics from the tangential velocity profile of the guide wire. Spectral arc length, or SPARC for short, is calculated from the normalized frequency spectrum of the velocity profile, with lower values corresponding to smoother motions. And this metric belongs to a set of movement smoothness metrics that are commonly used in robotic rehabilitation and human motor control research. In addition to SPARC, we calculated the average velocity and the idle time of each tooltip. Idle time is defined as the proportion of time within a navigation task that the tool remains stationary. And this metric is a measure of the cognitive engagement of the surgeon and is significantly different across experience levels in other surgical domains. After running a one-way ANOVA for each metric, we determined that SPARC shows significant differences across experience level, with more experienced surgeons producing lower values of SPARC. Average velocity showed a similar trend, with greater experience leading to higher average velocities. And idle time showed the inverse, with greater levels of skill resulting in lower amounts of idle tool motion. Given that these measures can show differences across experience levels, we performed linear regression between the time domains of average velocity and idle time and with SPARC, and these result in high and significant linear correlations with SPARC. And from these results, SPARC, average velocity, and idle time calculated from guide wire motion are reliable measures of surgical experience level. Average velocity and idle time in particular are intuitive measures of a surgeon's motion planning ability. And these two metrics can be used to express SPARC in terms of simpler time domain measures. And these findings are a promising step towards further automating endovascular performance evaluation and towards providing these measures to surgical trainees as feedback. And thank you for your attention.